Yeah, so honestly, yeah, I feel like it's not even that. No such difference about it. Well, I never. Good night. I think I showed you in like, yeah, I'll see the last few pages. Because I need to listen to YouTube, you're trying to like. So you don't do that.
I think I sent you one.
One time.
You will like because I didn't when I was here.
You're only 21.
This one.
This one
I got that really. I'm really getting my hours in the first. I'm gonna be like the first officer to get their own house.
Oh, I didn't visit.
I feel like well, I feel like if everyone's still getting well, I feel like if someone out there like, yo, what's up, guys? Like, you, yeah, like just like please for me. Yeah, I'm making the up for a couple of you.
I already have a spot.
So, we've completed all the, up to page 19, we've completed all the FRQs that we need your response for next week's Tuesday quiz. It'll just be one polar and one miscellaneous, and we've seen all the different varieties of how the miscellaneous FRQ can look like and what can show up. Are there any questions up to page 19? Any problems that you want me to go over with you with page 19? So I really don't have any additional review sheets for you to prepare for next Tuesday's quiz. I feel like if you feel good about these 19 pages and the process of working through those problems, then you'll get a similar one on Tuesday. And it's going to be buffered by your homework grades. So, I mean, I think we should all do pretty well. No surprises there. So, but I will still have a help session Monday morning and Monday afternoon. If you do want me to work through any of these problems again. But I think you guys should feel pretty comfortable being able to study on your own, I feel, for these next, for the topics that we're going to expect. So if that's the case, I would like to shift over to some AB topics. These are FRQs that you've seen from first semester, but it's been a while, so I think it's good for us to kind of review these topics. So today, we're going to be working through pages 20 through 25. And then tomorrow we'll work pages 26 to 30. And if we're done early on Monday, I think on Monday, I'm going to maybe spend some time going over some tips and advice for the AP exam and the format of AP exam. But if we have some additional, maybe I'll give you packet 4 early and start working on packet 4. Packet 4, I'm going to split up into 2 parts. First part will just be AP topics. Second part will be just BC topics. Yeah, but then, yeah, your quiz will just be 2 FRQs, 1 polar and 1 miscellaneous. Okay, so if you guys can go ahead and start on page 20. And I will, after you guys had a chance to get started, and once you read the problem, I will kind of highlight some parts, especially like part C and D, that can be more challenging. But let's do this first, though. Let's on page 20. Let's wait, page 20. 21, yeah, sorry. 20 is a, oh, wait. That's AP, sorry. Yeah, sorry, 21. Okay. So on page 21, let me just highlight let me just review a couple of items with you. We know that for particle motion, we have that relationship between position, velocity, acceleration. From position to velocity, that's a derivative process. So we can think of velocity as x prime or dx dt. Acceleration is the derivative of velocity. So acceleration, you can also think of it as the second derivative of position. So position, velocity, acceleration. We can also move up the chain from an antiderivative perspective. To get from acceleration to velocity, we can get antiderivative of acceleration to move to velocity, and the antiderivative of velocity will bring us up to position. Total distance is the absolute value of the integral absolute value of v of t. Average velocity, depending on where you are, average velocity can either be average value theorem for the velocity function, or it can be change in position over change in time, depending on where you start. So even though average velocity feels like two different formulas, they're basically the same thing. They're just starting at a different point. So if you're starting at the position level, then you should do the slope. If you're starting at the velocity level, then you got to do the integral of velocity and then 1 over v minus a. I do want to, even though they look very different from each other, I do want to convince you that these are the same things. Because if we just look at this portion here, what is that going to turn into?
V of v minus v of a. I mean, p of x of v
Yeah,
minus.
right. So I'm going to, instead of p, I'm going to use x. So it'll be x of b minus x of a. And if I bring that denominator over, it's divided by b minus a, which is basically a change in position over change in time. Right. So depending on what you have in the problem, that's going to help determine whether you're going to use average value theorem or whether you're going to use just slope. But some things that have tripped students up in the past is when they see average velocity, they will think, oh, I got to touch velocity because they see velocity in the name, but you don't use velocity if you're doing slope. You're just doing change in position over change in time. And if you do want to use velocity, you got to go through average value theorem. Same thing, average acceleration. I'm not going to touch acceleration. I'm going to use velocity. It's change in velocity over change in time. Displacement is similar to total distance without the absolute value. So displacement is just x of b minus x of a. And then we can also rearrange the displacement formula to make the final equals initial plus displacement. Then there's some review items here. Increase and decreasing speed. You compare the signs between velocity and acceleration. If velocity and acceleration have the same signs, then increasing speed. If they have the opposite signs, then decreasing speed. And then increasing, decreasing velocity. We don't look at velocity. We don't compare signs. We just look at acceleration. Okay, so this should be A/B review. You'll have Riemann sums. You'll have, so see if you can figure out whether to use, what theorems will apply for parts C and D. Okay, go ahead and try that. And I will kind of highlight some of the steps once after a few minutes. Okay, so today we're just going to be responsible from page 21 and 25. So I think we can probably finish it all in class without having to bring anything for homework.
Okay, so for IPT, when declaring the discontinuous, do I include, is it like the endpoints inclusive or?
Inclusive, yeah.
With MVT and Rolle's theorem, it'll be continuous, it's brackets, differentiable, it's parentheses.
Oh. So. I just don't know that. Okay. Just I'll try that. Okay. No, but I need to test. Yeah, all these shades. Damage stuff on the side.
For page 21, I think part C and D is a good comparison of what IVT and mean valley theorem looks like and how they're different. If I want to guarantee a velocity of -5, that's not too difficult to do because I can look at my velocity sign, my velocity table and tell that my velocity is going to be continuous. And to get from -10 to 0, it's got to cross -5 at least once. So IVT allows us to say, okay, if I have a point, a value lower than my target and the value above my target, and there are no breaks in the graph, it's got to hit my target somewhere along that path. But for part D, if we want to guarantee where acceleration is 0, if you look at your acceleration line, you're not able to quite use IVT to get that to be to confirm, right? Because we can't guarantee just by looking at acceleration that it's ever going to hit 0 since all these values are above 0. But we can do this from a slope perspective, right? If I can show that 2 points has the same y value, then it's got to have a slope 0 somewhere between. So if I'm starting at 0, -20, and I go down to -30 and I come back to -20, that is going to guarantee a slope 0. If I can guarantee a slope 0 because of the fact that my graph is continuously differentiable, then that must be able to guarantee there must be an acceleration of 0, since acceleration is the slope of velocity. So we use a different line of reasoning for part D because the IVT doesn't quite work. You can either say rolls, you can say MVT, but rolls is more specific, but I think mean valley theorem can still apply. You just show that your 2 endpoints is going to produce a slope 0, and if your slope is 0, you know it's got to hit that velocity of 0 somewhere, or sorry, acceleration of 0 somewhere on that interval.
It's like, where did you think about this to make your IVT?
Good. Yeah, you're indicating the endpoints and you're indicating that comparison between the lower and higher value. Oh, good.
It's on the track. It's like why where you get the years from the 500.
Right. So
The area for you.
Mhm. This is page 21, right?
Yeah.
Okay. So do trapezoid approximation, total distance. So you want to take the integral of velocity. So the width is at 5, so it's 1/2 width height 1 plus 2. So 1/2 5. And you have 1 plus 17.
Okay, that makes sense.
Oh, wait, sorry. It's asking for total distance. So we need to change these to both everything to positives.
Okay. Okay, yeah. Thank you.
Yeah, you can always use yourself, just draw the graph. Oh, wait, yeah, you're right, yeah. Left and decreasing is gonna be over. Okay.
And then, right and increasing would be.
Over.
Okay.
Okay, so tomorrow I'll check pages 21 through 25. Hopefully you guys got through a good chunk of that. Then tomorrow we'll finish up the rest of the packet. Okay, all right, come get your phones.
Yeah.
So, so that's. Probably depends.
I signed up really late. I go to high school, I'm talking about this.
So, the wording.
So they're gonna start off with this page. Oh, I'm all in.
Yeah.
It's so many people.
Yeah, so. Then.
It's actually crazy. So, like, I have to like diagnostic criteria.
Our students.
Whatever, unequal health outcomes.
I still have like two people. Oh, yeah, I have a 90.
Yeah, so she definitely gone on because
Annoying.
and she was like, not really sure, so we have a research program. So you can research that. So I need to figure out how to work that. Either it doesn't go easy or just say, I'm sure. Wait, I'm going to the you know, I'm going lost every time. For that, my, oh, yeah. I know, right? I'm really excited. I love
I use my brain too much. Like, so like,
Yeah, I was trying to make it. I had track. I'm like. Like this argument as well. Somebody said try to track. They're like, they weren't worried about the event. They're like, Robert did. Yeah. I don't know. Like, no one cares if the event's happening or not, they just care if you're running. Oh, Who else is second 50 then? I'm not doing
Yeah, like we could get that, but I didn't know they leaked
Yeah, you've got it.
You're the answer for now, right? Yeah. You have like the quadruple. Right. So. One person.
I didn't know about that. That's very honest. I don't know if it's true. I think it's just a joke. There's no way. You just go near your solar.
It's long as you want to, count how far it's the ground's gonna be. And then you're doing the right side.
Big clear and push from 40 and then just out of the way.
You guys can sound like.
Big clear and push. ATL
After 145, it's just kind of like, and then two best scores, two best distances, sorry. Identify those distances, give this to one of the, officers, then we'll put it all into the message sheet. Okay, so it shouldn't be easy, but I'll have all this.
Yeah, I think there's one other person doing not.
So you have two people, one can make sure they're standing that line, the other person, just make sure that interact where.
Okay, so I should come in 7:45 AM tomorrow or?
Oh, you don't have to anymore. Yeah, if you're good with this, then, because you'll be there by like 12:45, 1 o'clock. You'll have time to kind of set up before the students get into it. They're going to start playing their games around 1:10, right after their lunch. But if you're here at 1, yeah, there's no time. Thank you. They're good.
Have a good day.
All right, see you tomorrow.